Maybe we can get started. It's 9:06 now, PST. Thanks to everyone for joining. Today we're gonna talk about UDF. What's really happening in the UDF spec. I made some changes the last 2 weeks, mainly according to our last think about how do we handle the name. So it turns out we want to support the named argument invocation. In that case, the name have to be consistent across multiple overloads. This is one of the thing. I think it's a good idea to make sure because one metadata JSON file will hold multiple overloads, right? And all these overloads, you can potentially have different parameter name, which is really messy when user have the named argument invocation. They have something like invoke one function, they can put the name equals to something. So it's really confusing for this kind of conversion. So last time we talked about how do we make that more consistent across multiple overloads. So the solution is to move that name list from the each definition level to the top level. Let me share my screen a little bit. Can you guys see my screen?
Yes.
Okay. Let me get to the first page. We have one nice diagram about this. And so we used to have the root. This is the root level, and this is top level metadata. And this is each overloads. Right now we call it definitions. So we used to have the parameter here, including the name, type, and documentation. Right now we move this up to this level, so that name will be consistent across all these overloads. This is one change have been made for that one. So if you look at the change, so right now we have a parameter name list, which is the global ordered parameter names. Name is across all overloads, and all overloads were like each individual overloads will take a prefix of this list in order. It's not necessarily full list always, because some overloads has like one parameters, other has like 2 or 3 multiple. So this name list will become a like global one, which hold all these name. If you add a new name, creates a new overloads with new name, the user have to add into this name list, so that the other will be consistent. We have a few rules about this name list. First, just as I said, each overloads use the first n entry of the list for its origin order, and name and the related order are immutable. So there's no way to change them. Otherwise, all these downstreams, all this engine, when they used to work, will fail. And only upon new names is allowed. Along with the name itself, we have doc. Doc is the thing describe the parameter. Doc is okay to update the in place in case you want to put more metadata or change for any purpose. And by move this to the top list, we actually did something else by so if you look at the definition level, we used to have these parameters, and this parameter holds all these name and types. Right now, we actually remove the type, remove the name, sorry. So we only keep the type. So name is not allowed to be here. So that every time the type still be here, as well as its default value. This is next change that I'm going to talk about. The type only type and default will be here. The name and document has been moved to the up level. Any questions? All right. So the second change I made in last 2 weeks is to add a support for the default value of parameters. This turns out to be quite a little bit change, because every time you add it to default value to one of the parameters, it makes that parameters optional. Then it covered more signature than it just have like 3 of them. We can take some example here. For example, we have this function. Then the first is the mandatory. The second and the third parameter has default value, which makes this function, these 2 parameters of this function are optional. That's where cause some compatibility issue across overloads, because you cannot have something like this. It's ambiguous when you have only inputs. When you call with one parameters, there's no way to find out which one you're gonna call. So this is not allowed, and this is also not allowed because it's conflict with this one. The other conflicts, like, for example, if you have 2 parameters and the set of parameters also has default value, make that also optional, means its arity is 2, then it ambiguous with this one. So having this one, 2 of parameters become optional, it means cover more signatures than just the 3 different parameters. All these algorithm, when it has the less number of the algorithm than this one, will have to be not allowed to create with some certain default values. That means every time we create overloads, we have to have some algorithm to check whether this is conflicts with the existing one, with some default values, optional parameters. And another thing we try to clarify here is, even though we have, for example, we have the second and the third parameters are optional, we still support the one with different types. This is overloads we want to support. For example, here we have full int, then full float will be supportable, because in that case, there's no ambiguity between them. And this should be supported. Of course, engine have to select to match the best, exactly match, or depends on what engine trying to do. And at the same time, if we have this full int, the first parameter is match, and the second parameter has extra difference, then we should still allow this happen by different types of the second parameters. Any questions?
I think that makes sense. My question is, like, especially the third example or the fourth example, would you be able to pass in
this one, right?
Yeah. For example, I can see like the last argument being like something like now or today, a SQL.
Mm-hmm.
Is that also allowed by the spec?
This is, by the way, this is definition, right? This is this means if you already have this definition, this overloads, this definition will not be allowed.
I can see that. Yeah.
If you input long for the last one, which one will pick, right? or should this be allowed? I think this will not be allowed. So there's no ambiguity there. Yeah, in that case, even you input now, it will still go to this one.
Cool.
Yeah,
that makes sense.
Because when you call with these two parameters, there's no way to distinguish the two of them. The last one is default. However, if you put this as a completely different types, for example, here is string, and here you just date, but remove the default, which will allow that happen. In that case, if you input a null, that's gonna be a little bit confusing, right? Now it does not have type, right?
Yeah, that's a unknown type.
Right. No, it does not have type.
I don't think it's an issue. I'm just curious.
Yeah. I think we can. Yeah. So that's a little bit combination with this one on null inputs. Usually, all this engine will support the return null on null inputs. If this is there, then there's no ambiguity. It just always return null on or null inputs. And the another is the one is call on null inputs means even you have null, you still have to call that UDF. That one has a little bit confusing because we might not know which one to call. It could be easier this one or this one without this default.
I feel now it's a separate discussion. Here we just look at signature if that's ambiguity or not. But if you have default value, the ambiguity is not allowed. Doesn't matter whether it's null or not.
Yeah. So it's not related to default value actually. If even for the normal value, for example, if you have something like for floats and for int, which one the engine should call, right?
Well, at least the signature is allowed. The UDF should be allowed. Just that during runtime maybe will fail, I guess. It's not the UDF registration is allowed. Just at runtime cannot resolve.
Right.
During invocation, they will fail.
Yeah. I mean, we can always fail for sure. But what I'm thinking is, especially for the columns, that actually, even if the value is null, the column itself already have type, right? Then in that case, we kind of still have the type information in the engine side.
So I guess the scenario, let's say we have full of int and full of float, let's say full of string. If you call full with a null, invoke full with a null, then it can match to either signature. I think that's the scenario we're talking about, is it?
Yeah.
Yeah, I guess in this case, should the engine just fail because can match either signature?
We can test out actually. Like Huaxing already made some DOC with registered template UDFs in the Spark side, so that I think Sparks will, if you explicitly pass a null, what will happen, right?
But it's a signature allowed, right? Full of int, full of string, those are valid to different.
Right. Yeah. UDF definition does not have this specific question. How do we like ambiguous between them? But maybe any have to make decision whether if the type information is missing, which one to call.
Yeah.
Okay. Cool. Let's take example. I also update the example. So first example is quite simple. We have this add one, and we have two overloads. One is integer, another is float. Within the same metadata file, EDF metadata file. So by the first change we're talking about is to move the parameter names on the top level. So in that case, we have these top level parameter names along with its documentation here, which is X. Then in the definition level, we have two definitions here. One is int, one is float. For each individual definition, the name will grab from this parameter name list, and the representation parameter only has the type information. For example, int. Here for this one is float. And we used to talk about whether we need to keep the name in this representation level, but along with the design, this one, it turns out may not be necessary. For example, we can put the parameter here by introduce another name. Say, okay, these the first parameter X in here, first parameter is Y or A. So that this body which is representation of that SQL could use different name. It has multiple implications. First, if we have different name here, that means engine have to do the matching according to its order, which is also a lot of work for engine. And there's two ways to match them. Actually, let me put something here so that provide a better understanding. So we can do something like this by change name. In that case, the body could be A+1 instead of the X+1. We discussed a little bit before for this solution. It provides a little bit of flexibility. Means every time you create new representations, you can potentially use different name, and that's flexible for each engine to implement. But the problem is on the caller side, you have to do the mapping between this name list against this name list. This is one question, and there's two ways to do the mapping. For example, if the caller do something like add one X, this is named function invocation, argument invocation. If the caller do this one, that means caller has to do this one because on this top level, it only recognizes this signature, right? Then the caller have to do name mapping between X and A. So the first way is to mapping X to just to A. In this caller side, it just replaces the name from X to A. The argument name. So it will become something like this. So within the so we'll change this code. I think one of the drawback of this method is it makes debugging pretty hard because you basically lose the information of X equals to 1, and you will always should see A equals to 1, which is kind of hidden information. Depends on the it's just the representation level. The user will be confused by this information. All these like institution logs, physics, logic. I mean, these planning, logic plan and physics plan will see this one. It's really confusing. The second is to replace the body. So the A+1 we will change a plus 1 to x plus 1. So there's no parameter change. The invocation still be consistent. It's always use x, but every time the function, the ending have to replace the parameters in its body, which also a kind of unnecessary complexity we introduce to the function invocation. And I think we at least when I discuss with question, I think we think this may not be necessary because the benefit of introduce this mapping, this naming for each representation is not so big to have these different like all this complexity from the caller side. And keeping the name consistent across all this representation with this parameter name list will be not so hard actually. Like every time when you create the function, you have to take the name from here. That's still doable, and it should be good. Okay. And that's pretty much for the change in last 2 weeks. And any questions? Or if you are new to UDF specs, I can answer any questions. And I think this will need a review. I've made it ready to review. Please take a look at this spec. The spec itself is quite not so complicated. There's this is just overlook of what we UDF spec. And I'm gonna update this a little bit later so that any newcomer can just look at it and understand it better. Cool. If there's no further question, we can close this earlier. And please take a look at this back, and we want to move forward with this one. Thank you, everyone.
Thank you.
Thank you. You
See you
find all the
next
work. I'll take a look
Thanks.
at it.
Sure. Thanks.
Thanks. See you later.
See you.